To start our notes, I'd like you to prep your notebook. We want you to stay organized, so a table of contents will help you do that. Get your title in, and then the three columns, I'd like you to have our date, topics, and page. And once you have that all set up, you can put in your first couple of titles, 1.1, coordinate geometry number 1, and 1.2. Include a date, and for the page number, you'll flip a few pages to get set up. You're going to need a ruler or a straight edge and a protractor, or if you have the geometer stencil, might recommend that too. So let's get started. A reminder when watching these videos to pause often, back up frequently. It's your job to understand this and retain it, not just to view it. Section 1.1, the building blocks of geometry. So I'd like you to flip a few pages, leave those blank, and then put this title at the top. The reason you want some blank pages is your table of contents might span 2 or 3 pages. So section 1.1, we're going to start with the building blocks of geometry, and we begin with a geometric point. Here we have point P. Here I have a bunch of points, and I'd like you to pick one of them that is special to you for some deep personal reason. Now, if I were to ask you to describe that point to someone else, you'd have a hard time saying, for example, you want the point that's on the left, kind of in the middle, but not the middle, but the upper middle. It's much easier just to say point B, for example. Now, these points are much larger than actual geometric points. For example, a tiny sesame seed on this bagel. It's a physical model of a point, but it isn't a point itself. Points have no size. They have no width, no height, no length. They are purely location. And the way that we name them is with a capital letter. For example, a capital letter P. The next building block of geometry is a line. We represent a line with the mathematical model. Here we notice the endpoints. If we put on some points, A and B, then we can name the line AB. You could also name it BA. Please note the double arrows over top. Now, a line is a straight, continuous arrangement of infinitely many points. A piece of spaghetti is a good model for a line, but a line itself is much longer, much straighter, and impossibly thinner than any piece of spaghetti. The third building block of geometry is a plane. So here we have the representation of a plane. We call it plane K. Notice it's kind of a scripty cursive K. And a plane is a flat surface. It has no length, it has no width. Sorry, it has length, it has width, but it has no thickness. Kind of like a piece of paper or a piece of rolled out dough. That would be a model for a plane. So these are the building blocks of geometry. There are so-called undefined terms. Because they're undefined, we have no suitable definition for them. But we use them to build new vocabulary. The word collinear means on the same line. The example we have, points C, D, and E are collinear. They are on the same line. I think of collinear similar to co-pilot or co-worker, co-host, co-owner. Right? In a similar vein, the word coplanar means on the same plane. So here we have 3 points, F, G, and H, and because they're on the same plane, we say they are coplanar. Another definition, line segment. Sorry about the bad writing there. A line segment is a line with 2 endpoints. Here we have line segment EP. You could also call it PE. And one last definition, we could talk about a ray. Geometric ray is a line with 1 endpoint. We'll draw a model. You could name this either RA or you could name it RY, but you'll note that the endpoint always comes first. One final note with the difference between equal and congruent. Equal has the two horizontal tick marks. Congruent has the equal sign with the little squiggle over top. We use equal for numbers or for measurements, and we use congruence when talking about shapes and figures. Let me give you an example. Let's say we have this triangle CAT, and the two red sides are both 3.2 centimeters long. So it is okay to say segment AT is equal to 3.2 centimeters. It's not okay to say segment AT is congruent to 3.2 because we use equal for measurements and congruence to talk about the physical things themselves. A few other things that are okay to say. We could say the measure of segment AT is 3.2 centimeters. We could also say segment AT is equal in length to segment CA. We could also say the measure of AT is equal to the measure of AC. Or we could say that segment AT is congruent to segment AC. We'll talk about this more tomorrow, so make sure you get this in your notes. It's not okay to say the measure of TA is equal to the measure of the measure of TA is congruent to the measure of CA, or the segment AT is equal to the segment AC. There's some differences here that we want to make sure we have distinctions for, so get them in your notes. Next, marking congruencies. We've got a couple of figures here. We've got an isosceles triangle, a rectangle, and a hexagon. Note the red tick marks indicate congruencies. We've got two congruent segments in the triangle. In the rectangle, we have opposite sides congruent. And in that hexagon, we see all 6 sides are the same measure, so we can include one tick mark for them. One more definition, we've got midpoint. The midpoint is the point on a segment that's the same distance from both endpoints. So point B would be a midpoint here because AB and CB are the same lengths. Point E is also a midpoint because of those congruence markings. You'd be tempted here to say that B is the midpoint of segment AC, but without any measurements or without any congruence markings, we can't say that. So those congruence markings are really important. We could also say point E bisects DF. The word bisect means cut in half, kind of like binoculars or bicycle, cuts in two. I think it'd be worth going back and highlighting the vocab words that you'll want to remember as we move on to the next section, coordinate geometry. So midpoints. If I asked you to find the midpoint of this line segment, you'd pull out your ruler, you'd measure it, and you'd cut that measurement in half. Where it gets a bit different, though, is when we're on coordinate geometry style, when we're on the XY grid. Instead, I'd ask you for the middle point on the XY grid. Now, the midpoint is the average of the X coordinates and the average of the Y coordinates. An example, if we have segment AB with those endpoints you see there, the coordinates of the midpoint would be, I'll first take the X points, so -8 and 3, add them up, divide by 2, and then do the same with the Y coordinates, 5 and -6. And so we get our midpoint of -2.5, -0.5. Last section is finding angles. This is section 1.2 for your notes. It warrants having a clear definition of an angle. An angle is formed by two rays that share a common endpoint. So here we have an angle, and you'll notice we have two rays that share a common endpoint. Let's call that endpoint A. So we have ray AT and ray AP. A is called the vertex of the angle. I think of vertex and I think of the corner of the angle. And then we have the two sides of the angle. You could name it in a couple of different ways. You could name it angle TAP. You could name it angle PAT. In both of those namings, you see that A, the vertex, is the middle of the name. You could also name it purely by its vertex. You could name it angle A. So, how do we measure the angle? You'll need your protractor for this. The protractor is the tool for measuring angles. First step is to place the center mark on the vertex, then line up the 0 line along one of the sides, and then measure along for the other side to figure out the measure of the angle. So the example that I have, you'll notice first we lined up the vertex, and then one of the sides is along the 0 line, and so the other side tells you how big the angle is. So in this case, it looks like it's about 60. Now, of course, your angle will look a little bit different, so make sure you pull out your protractor and measure it. So we could say that the measure of angle A is not equal to 60, but approximately 60. The reason we say approximate is because no measurement tool by humans is ever exactly equal. Some more definitions. We talk about congruency with angles. Two angles are congruent when they have the same measures. And you'll notice the congruence markings. That shows me that those two angles are indeed congruent. We can say angle NBC is congruent to angle FOX. Or we could say the measure of angle NBC is equal to the measure of FOX. Another definition, angle bisector. We have a ray that's an angle bisector if it contains the vertex and it cuts the angle in half. So with the image shown below, we say ray CD bisects ACB because angle ACD is congruent to BCD. So to recap, we talked about points, lines, and planes. We talked about definitions of collinear, coplanar, line segments, congruent segments, midpoints, and rays. We talked about special geometric notation for all these things. We talked about the coordinates of a midpoint. We talked about angles, how to measure angles, and identifying congruent angles and angle bisectors.